Good day, folks. I'd like to share with you the reverse transformer concept, something I talked about in my previous video. I called it the Super Meg. And the concept was basically running a transformer in reverse. And by reverse, I don't mean like primary to secondary instead and flipping that around. I mean actually the energy systems where the core is the primary channeling of the energy. Instead, we flip the roles around. So if you want to know more about that, it's in my previous video, and I have it linked to my forum, which explains all the mechanics behind it, all the details, even the choice of core materials and conductive elements to minimize the counter EMF interactions here. So sure enough, I have here to demonstrate the concept, because some people weren't sure if it was going to work and they were debating in the comments whether or not this is possible. So here's my driver basically, which is a flyback, very simple, basically Joe Thief kind of setup transistor oscillator here, where I got my center tap becomes the positive, and on one side is the base, and then on the other side is the collector, and then the emitter goes to ground here. So here is my coil, and in the center where you would put a core, I have my iron rod all around there. And I have my coil here, and I have the first probe tab, channel 1, connected on the flyback side, which shows around 400 and some volts, which is natural for this kind of thing. And I have the channel 2 on the... This is essentially a capacitor, folks. And the thing is, when you look at everything, this looks a lot kind of something you'd see from something like a Don Smith or something like that, right? And what it looks like, what I'm getting at, is not at all what is happening unless someone would tell you. So a lot of these projects may have been relevant to something like this, but they weren't telling us the internal mechanics. And unless someone tells you, you'd never know. For example, this here looks like an regular coil, right? But this coil is not just a coil, it's the actual core that's coiled around. So the coil is the actual core. So this just looks like a normal transformer, but I have a shield here, which is the tape on one side. There's a aluminum foil on one side, and then another one all around inside. So the tube is actually, the aluminum tube is actually the capacitor. It's maximizing the reactive gains. We're using the core just as a trigger to trigger this system to get a nice LC reactive amplification here. And the capacitor this way is indirectly coupled. It's a capacitive coupled, so much more efficient, okay? So what's very interesting is when I turn this on, by the time we put our probes on the capacitive side, which is very interesting, the positive and the negative spike comes in at the same time at opposite phases. So, or what I'm trying to say is 180-degree phase. So the positive actually neutralizes the negative. So I was having a primary issue with that when I ran it in AC mode without a diode. I was only getting like 1.5 volts, because most of that, because you know the two waves at 180 degrees destroy each other, right? So by circuit design, what I'm getting at is this is also a very efficient scalar wave generator, and I'm not even there yet to interact, but it's just like a byproduct at this point. But it was very sad when it came to the traditional output. So a quick fix was to put a diode there on the loop, and that cancels out one part of the phase, so, or I should say the cycle, so that it don't interfere, and all of a sudden I was getting my 24 volts or so. And the spike happens at the same time as in the oscillator, so this helps a lot with the counter EMF actions. And of course, by being aluminum, the capacitor plate itself doesn't contribute a massive counter force. So I will show you how this works. So basically channel 1 is the yellow, channel 2 is blue. So yellow is connected to the flyback. That one will get like 400 and some volts, and the blue one is the capacitor output here. So I will connect the battery here to the center of the coil to feed the power, and you'll see what happens here as I touch it. See that what I mean? So the negative spike comes at the same time now, and on the second channel we're getting 24 volts. and it's at the same negative, or we're not seeing the positive because we're blocking it out with the diode as I was showing you. But what I'm getting at is it appears it's looking very good that the spike coming out of here comes from for free and is completely decoupled essentially from the source over here. And there is basically no or very little counter EMFs by design of this whole setup in reverse here. So it is looking very good that all we need to do in theory is have more of these taps here, and that's what determines the limit of how much we can pull out of here. So careful design on the coil, because this was iron. I had to make sure that none of them were touching. So it looks like a thin wire, but it's pretty heavy, you know, when you're wrapping that around and you can't move. So I worked hours just on this core coil here, and it's working very well, and I'm very pleased with it. And here's a basic circuit diagram that I basically did on the spot here to show you. This is basically the flyback, the coil here that's over here. And here's your core going through it. And here's the C1, which is the core coil. So with the inner and outer foil, aluminum foil layers, that's our capacitive, indirectly coupled. And that's a 24 volt pulse output that I was showing on the scope here. So very clever mechanism, folks. And it's looking very, very good. I'm eager to do more experiments with this. Of course, these values are very primitive. It was just to test the concept of running the transformer in reverse. I had written a little diagram of the crude fundamentals. I wanted to test it. I haven't tested it. It looked good in theory, but now I tested it. It seems to work super. So we'll have to look at better values, resonance, and all that. I haven't bothered with any of that. I just wanted to see if it would work. And so far, so good, folks. So yeah, again, I will leave it at that. So folks, just some observations. This seems to be a very promising approach. I've got a lot of experiments to do to try and introduce more taps, to enhance the core, maybe thicker iron and things like that. And there's just so much to do here. There's even the oscillator. This was just crude to see if it worked. There's so much improvements we could do on the oscillator. We could take advantage of the feedback, the inductive kickbacks, the resonant amplifications, ground loops, and the list goes on and on. And I haven't even experimented with those concepts yet, apart from driving the system. You know that the coil taps is one thing, but if we can maximize the oscillator, why not, right? So I'm convinced that this thing could probably run at just a few milliamps, which is very good, because at the end of the day, if I could get maybe, and that's a big maybe, if I can get the peg cells to drive this thing, it would become very interesting as a device. So with that said, folks, I hate to be in this position again, but I'm going to have to regretfully ask if anybody wants to support my research once again, because as you know, with this stuff here, I had some meters and whatnot, but a lot of the Chinese stuff, the firmwares get corrupted, or if they stay on too long, they overheat. So a lot of the test equipment I got is pretty well already no longer functioning, unfortunately. So with that said, playing with reactive power and things like that, you really need like old-fashioned equipment, the old surplus stuff, analog meters. And by analog meters, this is kind of like a scam in today's shopping experience. You search for an analog meter, it's a digital meter, all digital ICs, but with an analog reading. That's not any better at the end of the day. You want real analog meters that have the internal analog circuitry to measure various current and voltage sources. Now, if I could have some of that to experiment with, it would be a lot more useful to understand exactly in more details what's going on. And of course, there's everything else on that list as usual. It could be something as minimal as electrical tape. It'll be very well appreciated, to anything from test equipment again, and anything in between, folks. I'm really into the surplus stuff, the older equipment. Even if there's stuff that isn't working, I can take it apart and use some of the stuff. I would actually rather, have old stuff than, I feel bad when someone buys me something brand new and then, without my
nothing I did wrong specifically, but it's a Chinese product and it fails, like 2 months down the road. So that's not fun for me or the person who tried to contribute, right? And it's not their fault. It's not my fault. And, it's not up to me to go back to them and say, look, that meter's screwed up. I need another one, right? So I do what I can, and this is the field, right? Sometimes there's unexpected current spikes, and you don't know why, and sometimes accidents happen, right? I mean, look at Bedini. He said himself how many transistors he blew across the room without realizing why until it was a meter that was in line that caused all the trouble, right? So with that said, I really want to advance, but I'm missing some basics now. Again, I'm down on meters. I only have that little meter now. So the scope still works fantastic, by the way, and to that individual who donated me that, very, very thank yous again for that. It's been working superb. That's one of the things that is basically an absolute must, and one of those things that hasn't, randomly died on me. I guess it's used to dealing with pulse voltages and that sort of thing. So it's been very good to me. I don't want to jinx it though, because it's the only one that works well that I got. And of course, in my situation, I can't accept money, just raw money, but I could accept gifts. So if there's something on eBay or on Amazon or anything you want, anything at all, even generic stuff, folks, capacitors, transistors, reeds, relays, anything at all. I'm not fussy. It's all very, in these projects, the generic stuff you can ever have enough of is what I'm getting at. So with that said, again, I'm gonna ask folks if anybody could, if you have a few dollars to spare and old equipment mostly, I'd be really interested if you could help support my research one more time, and I'll do what I keep doing and showing you the circuit diagrams and the failures and the successes along the way. That's all I can do. But with that said, folks, I don't want to feel bad. I don't want to make guarantees and false promises. You see, like in this field, you never know what the outcome is. So you got to basically assume, I hate to say this, but you got to assume it's not going to go anywhere. But if it does, well, wow, right? So with that said, I'm going to leave it there, and I'm pretty sure my intents are pretty clear by now. And I keep encourage everyone to participate in the comments and share any information you may have that's relevant. And with that said, folks, I'll let you go. Until next time, thank you all.